Thank you. I'm going to be talking about building platforms with Angular. Just to introduce myself, I'm Jen Bourey. I'm currently the tech lead on Google Cloud Platform's client infrastructure team. And before I joined Google, I had a bunch of experience working on open source portal platforms, many of which I did front-end engineering for. Today, I'd like to talk about some of the challenges that we faced when creating a large app with Angular. Some of those include managing code size, sharing code, and avoiding conflicts. Also, making changes while ensuring code quality. So just to give you a little bit of context about our application, I work on the Google Cloud Platform, which is a unified web console for cloud development. And that includes things like logging and monitoring. It also includes resource management. So for example, if you wanted to spin up or shut down a VM or work with a database. And it also includes a number of interactive features like code editing and debugging. We use a number of different JavaScript libraries, including Angular, of course. We also use something called Google Closure, which is an open source tool that gives us things like type checking and dependency management and compilation. We also use a number of internal Google UI component libraries. This probably won't be true forever. We're really looking forward to adopting some of the new Angular material components. And we also have a number of feature-specific external libraries, like D3 and CodeMirror. Our project is one of the biggest Angular-based applications at Google. It currently includes somewhere on the order of 200,000 lines of JavaScript and template code, and that does not include comments and whitespace. All compiled, that adds up to over 25 megabytes of JavaScript and template code before it's compressed. Google is a big global company, so we are also working with dozens of teams across multiple offices and multiple time zones. That's certainly common at Google, but it does add to some of our coordination challenges. So contributions to our project include a number of core teams, which are responsible for doing things like maintaining infrastructure and building shared libraries and UI widgets, and also includes a number of contributing teams that typically do domain-specific feature development. My team is one of the infrastructure teams, so I view our users both as the end users who will eventually interact with our web page, but also the developers who are going to be developing for our application. So we're really focused on trying to build a platform that will be a pleasant place for people to do development and on building libraries and frameworks. One of the big challenges that we've encountered is managing code size. So having a single page app with over 25 megabytes of code, obviously that's really too much for a user to download in a single request. Our users would really not be happy with us if we pushed all of that to them, even if it was gzipped. That certainly affects download time for the initial page load, but even if it were cached, parsing that much JavaScript would really not be realistic. Also, not all of that code is used for a single view. We might have a user visit the App Engine page, at which point they don't need to see all the code for, say, Compute Engine and logging. And some of our users may only be using a couple Google Cloud features, so they might never need some of that code. The way we've handled this within our application is to use lazy loading. So we first divide code into modules. That's done using a Google-specific packaging system. That system works with our dependency management system and even allows us to ship different code to different users. We might ship some things only to internal users first just to try them out. But you could use any packaging system that you wanted to accomplish this. Next, what we do is register a placeholder route for each lazy loaded path. And I'll give you some examples of what these look like in a minute. We also have a new injector that's registered, and what that does is it forwards whitelisted lazy loaded changes to the original injector. So we have a whitelist of providers that we think it's safe to allow later configuration for. And of course, the route provider is one of those. When the lazy loaded module is loaded, it registers its real routes, after which we delete the placeholder ones and call route.reload. So if we can imagine that we have a sample lunch application, yes, I wrote these slides when I was hungry. We might have a taco subpath and a pizza subpath, both of which are separate lazy loaded modules. So we could view those as separate features. So when we start, these are just registered with wildcard paths that just point to the module. We don't actually know what any of the sub-URLs are. We don't know what any of the templates are. We don't care. And then we publish all of those routes as a constant. And inside our lazy loaded module, the route provider sets up all the routes just like it normally would. The key piece is that this module is not in the dependency list of the main app. So when the main app loads up, it doesn't know anything about this module, and there's nothing that's going to break because those pieces aren't there. We have two pieces of setup code in our core application that get all this wired together. So in a run block for each module ID to path mapping, we go through and register this load.js and reload method on the route provider. So what this does is it basically says, OK, we're going to load up the JavaScript code, and then once it's ready, we're going to call reload on it. And then we also make sure that our cleanup code is registered. So this is just taking a look at the route resolve, looking to see if that method is still there. If it's not there, we must have already done all the lazy loading. Just ignore it and move on. If it's still there, do some cleanup. So if I were a user accessing the main lunch page for the first time, this is not a lazy loaded route. This just works as normal. I visit the URL. I get some initial code downloaded. This includes Angular. It includes our base application code. And that sets up all the route mappings for me. So we have the regular lunch thing that's already registered. And then we maybe have our custom lazy loaded mappings. Now, once I go ahead and move to the lunch pizza URL, we're going to have to start downloading that lazy loaded code. So the new JavaScript module is loaded. And then at that point, as it loads, it replaces those wildcard mappings with the real ones. And at this point, route.reload is called. Angular sees that new mapping and will show me the content that I am supposed to be seeing on that page. Another thing that I think is really important when working with large applications is having a plan for sharing code. And there are a lot of good reasons to do that. First of all, this keeps code size down, so you're not going to have as much code to begin with. It also promotes product consistency. So when I move across the application, I want it to feel like something that was developed by a single entity. Interactions are similar. Things work the same on every page. It also gives us an abstraction layer that helps us iterate in the future. So if we want to make some sort of change, we can do it across the entire application in a coordinated way. It increases feature developer velocity. So if I'm a contributing developer, I don't have to start from scratch for every feature. I can use a number of services and directives that our team has already been provided. It also improves quality. As you have more and more features using all of these different services, you get a lot more testing. And if you fix a bug, you can fix it across the entire product. And I think code sharing is a place where Angular really shines. Angular directives are a great match for building UI components. So in our application, we have things like icons and dialogues. We also provide directives for form components, tabs, table sorting, and a number of other UI widgets. We even have some non-visual directives. So for example, you could do something like track visits to outgoing links using a directive. Services are also a great place for sharing business logic. We have services for things like URL management, caching, Google Analytics tracking, and error handling. One thing we've occasionally found challenging with Angular is avoiding conflicts as we're building all of this code. As I mentioned, we have a number of different distributed teams, and it's really important to make sure that we don't accidentally reuse the same names or namespaces. Angular has a lot of world-writable global state, so particularly things like the root scope, any feature can write to, and that would potentially affect other features. The module, service, directive registrations are all things that could be accidentally overwritten by another feature as well. So we have a number of different things that help combat this. One of the tools that we use is visibility. So our build system actually allows for package-level visibility. And we use this to ensure that features can't use each other's code. They can only use code that's specifically been added to our common directory. So in this example, the SQL and logging features couldn't use code from each other. They could only use common. And this is enforced at the compiler level. This helps ensure that code that is written by a feature that might not be actually intended to be used as an API doesn't accidentally get used that way. And it also helps us promote code into common. So if the logging package decided they wanted to use something from SQL, maybe they could help get it into common. And then we would know that it was there and other features could start using that as well. We also support visibility at a little more fine-grained level. This is something that's provided by Google Closure and is also enforced by the compiler, but we can mark particular methods and properties as either public or private. And this is really great for building common APIs because we can ensure that a particular property is not writable by the end user of that API. I'm sure many of you have seen recommendations to pick a unique namespace for your project when you're building directives and services, and that helps prevent conflicts with Angular or with some other library that you might be using. We've extended that concept and asked every single feature team within our product to pick a globally unique namespace. That's really great for debugging because you can just look at some code and just from the namespace be able to tell exactly where that code is coming from. And then we also have a separate namespace for common code, so it's really easy to identify what code is coming from common. I mentioned that root scope is world writable. We typically discourage people from doing that just to prevent confusion. Many of our directives also use isolate scope. And this is because if we have some sort of scope property that's public, there's some chance that it might eventually conflict with something that's used by a feature team's controller. As we get user feedback and do user research, we really want to be able to make iterative updates in our product. And we want to be able to make those in a coordinated fashion sometimes. So sometimes we have a global change that we feel like would be jarring if we made it on only one page at a time. We really want our application to be consistent. So here's an example of a global change that we actually made last year. Our form fields used to be, or labels for our form fields used to be next to the input box, and we moved them above the input box. So it went from this to something that looks more like this. The way that we typically make these global changes is to use a flag system. So our backend publishes a Boolean value indicating whether or not some new feature is enabled. And then we have a flag service that can inject that into things like directives and controllers. So in this example, for that sort of form change, if we had a form directive, which we do, we can potentially pick a different template based on whether that flag is enabled or not. And then even within the link or compile functions, we can also make behavioral decisions based on that value. This is another example of a global change that we made in one point. We decided to change our URL format to be something that was a little more friendly. And because we had a global URL service that we used to build all URLs, we were able to make this change at one single change across the product. In some situations, it might make more sense to make changes on a page-by-page basis. When we have these sort of changes, typically what we do is we take the original directive and register a second copy of it with a beta suffix, and then move pages over one at a time. So we could clone that directive or just re-register it with a different parameter, and then change each page individually, make sure each page looks great before we ship it. And then once everything is migrated over, we can rename that new directive back to the old name and delete the old code and do some cleanup. Upgrading Angular is also another global change that you might need to make at some point. We recently migrated to Angular 1.3, and we're really looking forward to adopting 1.4. We relied very heavily on unit and integration tests to do that. So we ran through our entire tests, fixed anything that didn't look right, and then did some additional manual testing. We're working with the Angular team on 2.0 migration strategy. I believe there's a talk this afternoon on that. So we're really looking forward to that change as well. I wanted to mention that we actually didn't start out on Angular. And we actually adopted Angular after our project was already in production. So you can still switch, even if you're not using it yet. We adopted a page-by-page migration and kind of worked from the outside in. And we did this because we were really attracted by the smaller code size and felt like we could achieve a higher developer velocity. So as a first step, we applied the ng-app to the entire page and added some navigation directives into the page, and then made the main content viewport be this ng-view. And we migrated pages on a page-by-page basis. Anything that wasn't actively mapped in the route config just fell through to our custom code that continued to handle the URL mappings just as it used to. Even within those Angular pages that we had, even within pages that we had migrated to Angular, we kind of also worked from the outside in. So it's possible to wrap some of your existing code so that you don't actually have to migrate everything over at once. So you can use directives to wrap some of your existing UI widgets. You can also use services to encapsulate existing business logic. And that tends to work particularly well if you add in things like promise support. If you want to, you can eventually convert this code over, but you can actually run for a very long time with code that's just wrapped in a sensible way. As we make global changes like this, it's really important to ensure that we don't accidentally break anything and that we continue to maintain our product quality. All code is reviewed at Google actively by somebody else before it's checked in, but it's still much better to prefer automated checks whenever we can. So some of the different kind of checks that we have are first JS compilation, so that helps catch things like compiler errors and typos, make sure that arguments actually match. We currently use Clojure for this, but you could certainly use something like TypeScript instead. We also have a number of checks that are run before code is submitted. And these are great for enforcing project best practices. So they might include things like enforcing usage of custom filters that we prefer, preventing people from accessing the root scope. It can also help make sure that things like debugging statements aren't accidentally checked into the code base, and we can enforce our lint rules. We also use automated testing to verify our changes. For unit tests, we use Jasmine and Karma, and those are actually run before submission. So if there's a test that's broken, the code can't be checked in. We also have a number of protractor-based integration tests, and we run those after check-in. So once code's checked in, those run in the background, and then if something breaks, it's flagged. We found it really helpful to have shared helpers for some of our common UI components. This is particularly helpful on the protractor side. If you have some widget that has a really complex DOM structure, it's helpful to publish those selectors and maybe some helper methods so that your feature developers can write integration tests more quickly. That also gives you a nice abstraction layer, so if you change that widget, you can also change the test helper. We've occasionally run into more subtle failures that it's kind of difficult to catch with some of those automated integration test strategies. So the thing that we find most troublesome is sometimes missing directives. So in this example, we have an attribute-based directive that applies a custom CSS class. And over on the left-hand side, that's what the directive is supposed to look like. If the directive just isn't applied, maybe somebody forgot to include it in the dependency mapping, you just get that same element without the CSS class. So if the protractor test was looking for just an input element, the test would still pass. Similarly, this is element-based template directive that adds a little icon and some wrapper classes. And HTML allows arbitrary elements. So if this directive wasn't mapped, there's no error on the page. The tag's just included in the HTML as is, and it winds up just being text. So the way that we're currently exploring is to use screenshot comparison. So in this view, I have a test page that uses a couple different flavors of this little message widget. And on the top is what that page is supposed to look like. And then if I remove the dependency mapping, you get that text on the bottom. And then our screenshot comparison tool can actually show me a visual diff of where all the pixels don't match between those two views. We're using an internal framework for this right now, but there are some publicly available ones as well. So my recommendations for working with large Angular applications would first be to create shared abstraction layers. Those are really important for things like consistency and developer velocity and the ability to iterate. Watch your JavaScript download size and maybe adopt some sort of lazy loading strategy if you need to. And then finally, to ensure thorough test coverage. If you want it to work, you should test it. Thank you.
Thanks, Jen.